Hello, today we're going to talk about exponential functions, growth rate, decay rate, and interest. Basically, growth and decay rate is just interest, annual interest is what it is. But here are two formulas for it. So with the growth one, with our growth rate, wrong marker, you have the function f of x equals a, which is just your original. In this case, it's your principal when we get to the interest formula. 1 plus rx. This right here, and I'm going to write the decay one down here too. Alright, so this right here, this is both just your growth or decay rate is what it is. Now it's an annual rate is what this always is, annual. So that means one time, a year or whatever, all right? The X is up here, stand for the amount of time in years. So if I say 6 years, I'll put 6 up there. If I say growth of 5%, I have to switch it to a decimal. All right, here's our first problem. So rate of growth is at 5%. After 4 years, how much do you have if you originally have 20? These are just some generic numbers that I'm using, nothing fancy about them. So it's a growth rate, so I use my growth rate function. F of x equals a, which is my start, basically my A1, 1 plus the rate times the time. All right, so my A1 is my original number here, which is 20. The 1 stays the same. Now the rate, it has to be written as a decimal. You can't put 5 in. So to do that, you put whatever the growth rate is over 100 and divide it, and that gives me 0.05 in this case. You're basically just turning the percentage back into a decimal by dividing by 100. Then my time is 4. And then we solve it. You'll add these together. If it actually asks you for the growth rate, that is what it is. It is 1.05. Right? Because it's going 105% every year. Or 105, whatever. So 1.05. And your final answer to this one is 24.3 when you do it all out. So you do 1.05 raised to the 4th times the 20, 24.3. And that is how you do growth rate. Just plugging everything in. All right, so this is problem number 2. Rate of decay is at 12% after 6 years. What do you have if you originally had 100? So this is actually written pretty weird. So if I say John has 100 something, it decays by 12% per year. What is it worth after 6 years? Basically. When you talk about rate of decay, you usually talk about like value on a car, value on a house. They all usually go down after years. Sometimes they go up, but usually they decay. All right, so f of x equals our decay. The other way to say decay is it goes down or loses interest, anything like that. So our original here is 100 times 1, which is just 1. Then our rate is 12. To find our rate, we take whatever it is and divide it by 100. That gives me 0.12, and x is our number of years, so 6. So if they ask you for what the decay rate here is, it'd actually be 0.88. All right, so when we do all that out, we get 46.4 is what's left after it decays at 12% for 6 years if you originally have 100. So that's the decay rate, and that's what you have left after 6 years. All right, here is what is called the interest formula. All right, it is actually derived from the growth and decay one. Growth and decay go by annual. All right. That's where this n comes in. So if I make the annual 1 for both of these, you get this formula right here. besides the P. The P is just your A1 or your original amount that you have. So this is called the principal, all right? And all that is, it might be, I don't know, it's one or the other. But this is just your original amount. All right, the R is still just your rate. Now if it's a decay rate, like it's going down, you'll use the negative there. So I'll put a plus or a minus, whatever you want. It doesn't matter. You just have to decide whether it's a growth or decay. All right, this N is new. This is just how many times per year. So with the growth rate and decay, it was always once a year. All right, so it was always one, so you just get rid of it. But now you can use stuff like biannually, which is 2. You can use monthly, which is 12. You can use daily, which usually doesn't happen, but that'd be like 365, weekly, 52, stuff like that. So this changes up. And the T is still just your time, and the A over here is just your final. It's what you finally have. All right, good thing about this video is you can stop it and write all that down. So original amount, how many times per year, how many times in year. This has to be in years, the time. That fools a lot of people, and R is still just your rate. All right, I'm gonna go through 2 of these, and then I'm gonna show you one other example, and then we'll be good. All right, this is example number 3. So I have $20 that I put in the bank at an interest rate of 5%. It's compounded biannually for 4 years. So this is how I like to do these, because there's a lot more into it. I'm looking for this because it doesn't give me my final amount. It gives me my original amount, which is the principal. Gives you the rate, which again, you take 5 and divide it by 100 to get 0.05. How many times per year? It says biannually, so 2, and it gives me 4 years. So I plug all this in. 20 times 1 plus my rate of 0.05 over 2, that's 2 times 4, right? And then you solve it down, and you end up getting $24.40. So after 4 years, compounded biannually by 5%, you start with $20, you end with $24.40. And that is how you do interest. That is interest growth. I'm gonna do an interest decay now, such as if you have a car or something. All right, this is actually a rate of decay problem. In this case, it says depreciates. It's the same thing. The only difference here is it's going to be monthly instead of annually, so we have to use the interest formula. So A, P, R, N, and T. It gives you the original amount because John paid $6,000, which is your principal. For a car, it depreciates by 10%. To get 10%, you take 10 and divide it by 100 to get your rate. Times per year, it says monthly, so 12 times. What's it worth after 8 years? Plug everything in. A equals 6,000, 1 plus the rate over monthly, then 8 times 12. And you get, when you do all that math out, the car is worth $2,686.95 after 8 years if it depreciates monthly by 10%. And there you go. The only difference between the interest formula and the growth and the rate decay is these are annually, this is multiple times per year. All right, this is the last one. I have to hurry up because I'm zooming in here in a second. This is whenever you see the word continuously when it deals with interest. Whenever you use continuously, you're going to use the PERT formula. So if I tell you your principal is $3,000 and it's continuously it's compounded continuously at a rate of 12% for 5 years, what are you going to end up with? So throw it in, 3,000. In this case, they want you to use for your E 2.7183. There's also an E on the calculator that you can use. So 2.7183 raised to the R and the T, so 0.12 times 5, and that gives you $5,466.38. There you go. All right, this has been a lot, but this has been exponential functions with growth and decay rates, interest, and the PERT formula. I hope this helped, and good luck.